Okay, 38 is the question came from what do we do with the number in front? Well, the simple thing is you divide by it, but these are very different questions. So this is a good comparison to make. I'm going to put these side by side and work through the different strategies because you can't think of ln and e as being the same thing. They're not. They're opposites in a way. I'm going to subtract 2 from both sides, so I get 3e to the 2x equals 48. And then we're going to divide both sides by that 3, so I get e to the 2x is equal to 16. You should be able to at least get that far with your algebra knowledge. And now we have the new operation. On the left side, I have exponentiate with base e, and I want to undo that. And the opposite operation of exponentiating with base e is to take the log base e of e to the 2x, or the log base e of 16 if I do it to both the left and the right side. But we don't call it a log base e, we call it a natural log. So you don't have to show this step right above because this is kind of just a notational thing. We're not ever going to write that. On the left side of this equation now, the natural log of e to the 2x is just 2x. That's the undoing part. So you have 2x is equal to the natural log of 16. We can get a little bit clever with this, but let's get x by itself first. I get x is equal to the natural log of 16 over 2. But let's get a little clever. We know that 16 is equal to 2 to the 4th power. And I know that by the properties of logarithms, this is the same as 4 times the natural log of 2. And if I divide the 4 and the 2, I get 2 natural log of 2. So this is a better version of that answer, whereas this is okay. I could also make this, if I want to go a different direction, be the natural log of 2 to the 4th is the same as 4 squared. So that would become 2 natural log of 4 over 2, or the natural log of 4. So all of these 3 are equal to each other. And you should know why that is from stuff from the last chapter we did. So that's 38. Let's talk about 42 for a second. 42 is a little bit more of a tricky problem on how to get rid of that 2. So let me slide this down to its own little place and let's talk about this. I do need to get rid of the 2. So good instinct on getting rid of that, but I'm going to do it by making the 2 become that exponent. So this is the natural log of x squared equals the natural log of x plus 1. Now I can exponentiate both sides and drop those and say this is now just x squared is equal to x plus 1. And if I proceed further, let's just do the quadratic formula on this. So I get x is equal to the opposite of -1 plus or minus the square root of 1 squared minus 4 times 1 times -1 all over 2. I would get x is equal to 1 plus or minus root 5 over 2. Okay, you do have to do a little bit of analysis in the original problem. I know that 1 plus root 5 over 2 is a positive number and 1 minus root 5 over 2 is a negative number. This is not going to work because if I plug it back in up here, I'd be taking 2 times the natural log of a negative number. You can't take the natural log of a negative number. So my only solution is going to be x is equal to 1 plus root 5 over 2. Not 1 minus root 5 over 2. It is proper to actually reject the second solution, so don't just say it's equal to plus because it's the positive. We need to check both of them. I need to check that when I plug it back into the original problem, they would work. Okay.